Hello learners, welcome back to my YouTube channel. And today I want us to continue with the lesson from where we left back, that is under gas laws. And we shall be looking specifically at Graham's law. We want us to look at Graham's law. And under Graham's law, we first of all need to get the definition of the Graham's law. And then from there we shall have to solve some various examples as far as the Graham's law is concerned. So Graham's law states that under the same conditions of temperature and pressure, the rate of diffusion of a gas is inversely proportional to the square root of its density. That is, Graham's law states that the rate of diffusion of a gas is inversely proportional to the square root of its density, to the square root of its density. So, when we are going to express Graham's law, as it is saying, it states that the rate of diffusion of a gas is inversely proportional to the square root of its density. What do we mean? That the rate of diffusion of a gas is inversely proportional to the square root of its density. It is inversely proportional to the square root of its density. So for us to remove this, we have to equate a constant, whereby after solving, we shall come with the, for example, if you are going to be dealing with two gases, where you will label one of your gases as gas A and the other gas as gas B, we shall have that RA, where R is the rate, all over RB is equals to the square root of density of gas B, all over square root of density of gas A. And also, under this rule of diffusion, that is under Graham's law, we are also going to see that the higher the molecular weight, the lower the rate of diffusion. So what does that imply? That it is also equivalent to square root of molecular of gas B all over square root of molecular of gas A, which is also the same when we shall compare the time that will be taken, which will also be the same as time B all over time A. And whereby now R is the rate of diffusion, our D stands for density, our M will stand for molecular mass, and our T is the time taken, Yes. So there is the abbreviation of our letters, where R is the rate of diffusion, our D is the density, our M is the molecular mass, and our T is the time taken. Let us take an example. That is example 1. Let us solve an example. That is example 1. Example 1. Let me take an example. That is example 1. It is saying, for example, I can have one question where we are told, if it takes 20 seconds, if it takes 20 seconds. So let us look at this our example that if it takes 20 seconds for 200 centimeters cubic of oxygen gas to diffuse across a porous plug, how long will it take equal volume of sulfur 4 oxide to diffuse across the same plug? And we know that the relative atomic mass of oxygen is 16 and that the relative atomic mass of sulfur is 32. So, according to Graham's law, first of all, we shall have to look at the relationship that we have to use. We are given time, that is 20 seconds. Then we have the molecular masses of oxygen and sulfur. So, what are we going to do? We are having two gases. That is, we can have gas A, our gas A as oxygen gas, and we are told it takes 20 seconds. It takes 20 seconds. It takes 20 seconds. Then we are having gas B. We are having gas B, which we are told that how long will it take an equal volume of sulfur 4 oxide gas? You need to know the correct formula for that gas for you to calculate it well. So we have how long will it take sulfur 4 oxide gas. Sulfur 4 oxide gas. We don't have the time. We don't have the time. That is what we are going to get. But we can get the molecular mass of oxygen gas, which is, we know that one oxygen atom has 16, but there are 2 of them. So we are going to get 32 grams. That is the molecular mass of oxygen gas. What about when we look at the molecular mass of sulfur 4 oxide? We know that the sulfur is 32, but it is one atom plus 2 oxygen atoms. That is plus 16 times 2. So we are going to get that it has a molecular mass of 64 grams. So we go and look at our relationship where we shall be having time and molecular mass. And what do we know? We know that time B all over time A is equals to square root of molecular B all over square root of molecular A. All over square root of molecular A. So we have already labeled our gases that oxygen is our gas A and that the sulfur 4 oxide is our gas B. So we go direct and equate the information that you are given. So time B we don't have. We don't have. That is what we are looking for. For time for sulfur 4 oxide gas all over time A. Time A is oxygen. We are given it is 20 seconds. 20 seconds should be equals to what? Molecular of gas B. Molecular of our gas B, which is sulfur 4 oxide, it is going to be 64 grams. So all over square root of 64 grams over our molecular A we have in as oxygen gas, which is 20 seconds over square root of 32 grams. That is the square root, the molecular masses of that. So what do we do? For us to get our time B, we can cross multiply. We can cross multiply so that now we have our, so that now we can have that our time S, time of sulfur 4 oxide is equals to 20 seconds times the square root of 64 all over square root of 32. All over square root of 32, which is going to give us 28.3 seconds. Thank you very much for watching. Please subscribe, like, you can comment. You can also forward your questions that you want us to solve. We shall meet in our next lesson. Bye-bye.